It's kind of a quick run through. We're going to talk about some slides and go through the history of WebSockets just a tiny little bit, talk a little bit about the implementation on the browser side, maybe a little bit on the server, and then go through a demo of a kind of client-server chat application. So the agenda, we're just going to go through a short presentation with the demo code. Then we'll have some Q&A. And stop me at any point in this presentation to ask questions. Just kind of keep it open and flowing and stuff. And I'll defer it if we've got a slide on that particular subject a little bit later on. So I'm Jack Lawson. I'm Ajaxified on Twitter and GitHub and pretty much everywhere else on the internet. I'm an engineer at Airbnb, and we're hiring. Coolest company in the world, so if you're interested, talk to me. Kind of as a hobby, I like to build web games. I think it's a great way to experiment with a lot of new technologies, like WebSockets or like 3D perceptual computing and WebGL and all kinds of neat stuff. So, and right now is an amazing time for gaming in the browser. We have like the audio API, we have WebGL and Canvas, we have pointer lock, we have great browsers that are implementing all this. We have latest versions of Firefox and Chrome and Opera, and even IE10 is supporting WebSockets. And WebGL isn't across the board, but Canvas is everywhere, and it's hardware accelerated usually. It's pretty awesome stuff. And of course, we have WebSockets, which is amazing. And WebSockets has a lot of other uses besides just for gaming. At Airbnb, we have some internal tools where when we deploy code, we watch the status of servers as they get uploaded. So you could have that kind of thing. You could have a CMS for collaborative editing. Like you might have Google Docs where you have 5 people editing the same document at the same time and get those rapid updates. And that's because you have a live connection. You could have support chats like, save companies money rather than phones and things. So you could have live analytics. You could track users as they're using a website and watch the events as they're rolling in. You could watch server statuses. If errors start spiking, you can notify instantly. WebSockets are awesome. But of course, all these things existed before WebSockets. We had a lot of other technologies. We had Java applets. I know my old ISP used Java applets for support chats, exactly. And so you'd have to get on, you have to download Java, and then you have to wait, and then you install it, and then you have to patch all the security holes and whatnots, and that was a mess. You had Flash and Silverlight applications, which are better than Java applets, but they also require an additional tool set. So if you're working with HTML and JavaScript and CSS, you're also working with Flash, or you're also working with Silverlight, or you're using just Flash or just Silverlight, in which case, HTML5 versus Flash, we won't talk about that here, but we have comet connections, which are kind of a persistent HTTP connection, and they're really heavy on the server. And so we have these other methods like Ajax polling and like meta tag refreshes, which are nasty and messes, and those are things that we had before WebSockets. So what distinguishes WebSockets, what makes them so great? First step, they're bidirectional and full duplex. And so what that means is you have a client browser that is connected directly to a server over a TCP socket. So you make a connection once, and then you send packets of data with little tiny headers. And so versus HTTP, the headers are a lot smaller versus Ajax polling or something. And also that means that you have server push. So the server pushes you updates whenever, and you have a really simple JavaScript API to respond to events and data as they roll in. They're secure. They're secure to handshake and masking when you first make your connection. You can also use an SSL connection. You'll usually terminate that at some endpoint before sending it off to your application servers to make it lightweight, but application, whatnot. They're super simple. So to create a new WebSocket, you create a new WebSocket. I don't have an answering mic, but the other methods you have socket on open, on close, on error, on message, send and close, and that's it. That's the JavaScript API for dealing with WebSockets. It's super simple. Some WebSockets resources that are great. The RFC 6455, it's really, really readable. So if you want to know about the low-level implementation of WebSockets, Google it and read it. It's actually pretty awesome. And it was finalized just a few months ago, I think. So it's all great. Building Games, buildinggames.com is a website put on by Microsoft and Boku, an agency in Boston. I have an article called WebSockets A Guide, which again talks more in depth about the implementation, more on the server side, but also it hits some demos on the client side. And there's some other really good articles about optimization of WebSocket channels and data sending and whatnot. Then the Mozilla documentation is amazing. And also all these slides are posted on the meetup link, so you can get these later. You don't have to write them down now. So we'll actually run through the demo now. The project, again, it's on GitHub. And this thing is up. It's github.com/ajaxified WebSockets workshop. To get it started, it's really easy. There's 4 things you need to do. You need to install Node, which you can do on OS X or Windows or pretty much any flavor of Linux. Go to the project directory, install the dependencies, and then start the server. And so once you do that, you will have, once I drag them over, these are huge. Hello, resolution. Responsive design-ish. You'll have these little demo chat servers. You can run them yourself. And so you can plug in your name, Jack and Hi, and they appear in both servers because they're, all WebSockets. I know Dave. Fine. Right. Right, so super fast, super awesome. And so the amount of code in here is silly and small. And this is going to be difficult. So I'm actually going to switch back to mirroring real quick. Sorry about that. That'll be way easier than having to turn around. All right, cool. So, all right. So first, we'll take a look at the server. So as you saw, it goes back and forth really fast. And so how this all works. This is a Node.js app. So I use Node because it's really easy to do WebSockets in Node because it's super lightweight. It's really easy to install. It works anywhere. And it has this really nice library called Socket.io. And Socket.io is it's an abstraction over WebSockets. It works close enough to the base WebSocket JavaScript API that you won't really notice a difference except for a couple minor things. And it provides fallbacks. So if you're on a browser that doesn't have WebSockets, it'll use Flash sockets, or it'll use Comet, or Ajax polling, or various ways to do it. So all I'm doing here, this is JavaScript, this is Node. I'm making a web server. I'm listening on whatever port. And so one of the neat things I can do with Socket.io is I can listen on the same port as the web server. So I don't have to worry about firewalls or running WebSockets on one port and the site on another port. It's a TCP connection directly to, through port 80 or whatever you're hosting on. It's probably port 80. And then what the server does now is it says when I reach a connection, fire off this callback. And so whenever I get a message, fire off this function. So when I send a chat message to the server, it's going to emit that message back to all of the sockets. And so if I have 7 browser tabs open and one of them sends it up, it'll send back to the other 7. You can single out clients if you keep a user list elsewhere. And if you have questions about how to do that, we can talk about that. That's it. This is a WebSocket server with a chat server and 25 lines of code. Just silly. And then the actual HTML page is similarly very similar. It's a form with labels and inputs, just like you'd see anywhere else. Pull in jQuery. Because I'm using Socket.io, I load up the Socket.io library. I connect on localhost. So again, with raw WebSockets, it would be new WebSocket localhost. And you could do that with a Socket.io server. I bind the submit function to the chat form. And I say, if I have a message and a name, they're not empty, emit message with this data. And so in this case, message is a channel. So I'm saying on the message channel, send this information. This could be chat, or this could be Svalbard. It could be anything. It doesn't matter what it is. Clear out the message. And then just like below that, when I get a message, append the string of HTML with the name of the message onto the chat form. That's it. It's super easy. And so basic WebSockets work the same way. That's really about it. So I'd love any questions about how this works or why WebSockets or whatever's. Yes?
What's your raw socket issues?
Is it what?
What's your raw socket security issues?
Oh, raw socket security issues. There were originally, at this point, since the RFC has been finalized, a lot of security issues have been addressed. When you initially make the handshake to the server, that happens with some keys are passed back and forth, and it's pretty secure. And if you pack SSL on top of that, it's just as secure as any SSL connection. Yes.
Can you what kind of variables can you message? Like, can you submit an object, or is it just simple variables?
Mm-hmm. So the WebSockets, by default, accepts strings, and in the RFC, it accepts binary data, although the browsers haven't implemented that for the most part. In this case, socket.io abstracts that, so I can send in objects. Normally, I would JSON stringify objects and send whatever to the WebSockets server, which would decode that. Yes?
How minimal is the amount of state stored on the server for each connection?
Minimal is the amount of state stored in the server for each connection. Depends on what server you're using and what library you're using. For socket.io, I don't have exact numbers. There's also like a C# server, Alchemy WebSockets, which is very light. It uses microthreads, I think, C# magic. But it depends on what you're using.
Right.
Yes.
I don't know if you can tell me or tell us, but are you using WebSockets or Airbnb? And if you are, how many concurrent users do you get, an average? And
Yeah, so we're using them right now for some internal tools and for some features that we're testing. The internal tools I can talk about more. So we have a system where when we deploy code, we have a group of servers, X amount of servers, that are all connected to a WebSocket server, a socket.io server. So when you deploy code, they ping the server and say, hey, I'm updated. So all the developers could say, when I deploy code, what state is that code at? That's the use case that we're using right now that I can probably talk about.
So it's not being used for any public?
Yeah, correct. Some of the games that I'm building right now, I'm using socket.io. We're rebuilding this really old, awful HTML, uses frame sets game called Neflaria. And that we've demoed with some conversions to WebSockets. And we've had that with a couple hundred concurrent users using socket.io and an Amazon micro instance. And it's pretty solid. Yes?
I know you guys use Backbone. Have you found any uses for Backbone with Socket?
Backbone with sockets. There actually is a pretty interesting plugin for Backbone over WebSockets that replaces the REST calls with a WebSocket connection if one exists. And I've played with that personally, not with Airbnb, but with some of my games. And it's pretty neat. It depends on your type of application, because if you're doing something like a showcase of, I don't know, say you're a deal site, say you're Groupon. WebSockets doesn't make as much sense because you're sending a large amount of data once in a while. So an HTTP connection that can be cached makes a lot of sense. WebSockets makes more sense for something like a game or a CMS or some kind of an application where you have small amounts of data transferred a lot, because then the overhead of opening up HTTP connections plus the lack of server push becomes more apparent. Yes?
I'm not sure on this, but what are your thoughts on the alternative to the WebSockets? Something like pops out, develop better beans. Any thoughts on that?
I've seen PubNub a little bit. Is that a mobile thing? I don't know. Actually, I'm not super familiar with PubNub.
Is that going to be kind of a C-based environment? Where kind of cool WebSockets could be popular. I'm not sure what's going to happen with that. What RTC would you think of that? In relation to WebSockets?
Can you expand? What specifically?
What is the role of WebRTC and WebSockets? How should they integrate or not?
They're kind of for different cases. But WebRTC operates over HTTP generally, and so again, those make more sense if you're sending big chunks of data, versus if you're an active application where you're transferring a lot of small bits. You have to measure the overhead of, do I need server push? Because if you do, you should probably have a WebSockets application or something, or Comet, I guess, but WebSockets is cleaner. And also, what's the nature of the data that I'm sending and receiving?
You said it's HTTP-based, so that means that perhaps Speedy would work better with WebRTC than WebSockets?
I would think, yeah, HTTP 2.0 Speedy, yeah. So the difference with HTTP 2.0 and Speedy, so what's cool about HTTP 2.0, I don't want to get super deep into it, yell at me if I'm running over time. It keeps over in a server channel for server push. So it provides the push, but it doesn't provide the client to the server. So yeah, again, different cases. If you could do AJAX requests with HTTP 2.0 and achieve most of this if you're sending big chunks of data. Yes?
A header headers do you get via cookies?
Uh-huh. Yeah, actually, the header, I meant to bring up a demo. Actually, we could probably even take a look at that. It's really nice. You can send in cookies, you can send in, actually take a look at it. Because the initial connection actually is an HTTP request. It's an upgrade request. So it sends along any header data and information that you wish it to, network. So we can actually look at what that request may be. Right. Yeah, so you can see I have an accept. It sends over cookies. So in this case, I have some candy shop. I was playing with a chat demo. Response headers keep alive. And so, what was I going to say? One of the interesting things you can do also is you can also send in a custom protocol when you open up your WebSockets connection. So you can define your own format of data, I guess kind of XML and ES kind of thing, and define on the server, say, okay, I accept chat format stuff. And your client can say, I want to send you chat format stuff, and it'll connect or disconnect based on that as well. So that'll be, there's some additional headers you can pass on as well. But you get cookies, I guess was your question. Yes?
How reliable is the connection? Like, can you miss packets or get packets out of order or anything like that?
So the header is pretty good about saying, so when the WebSockets initial header for the first frame says, this is how large my frame is, this is how much data you should be expecting from me. So if anything's off, it'll toss it, and it's TCP, so it'll just send off the right packet, and it'll be assembled by magic on either end properly.
Okay, so it's reliable, basically.
Yeah, it's pretty reliable, yeah. And if it does crash, you will have to manually reopen the connection. Okay, yes?
One thing I heard about was, I'm not sure if this makes sense, that WebRTC using basically the WebSockets or your UDP. Does that, I mean, when we were here last time, does that make sense to you?
It's interesting. I mean, there's lots of opinions about whether WebSockets should be UDP instead of TCP. I don't have a super strong opinion. TCP is good for me, yeah.